Hello and welcome to my presentation on plasma. But before I suddenly jump in with massive words and unseen equations, I'd like you all to think, what actually is plasma? I mean, sure, if you're a sci-fi fan, you're guaranteed to have heard about it through games, movies and whatnot.
Anything else?
Phased plasma rifle in a 40-watt range.
Did you know plasma makes up a whopping 99% of the universe, making it, with ease, the most abundant form of matter? Yet, strangely, few people know what it really is. Now, because I don't feel like boring you for the next 5 minutes with long descriptions and equations, I will teach you about plasma by comparing it to something society knows and loves. Drumroll please. The LightSaber! And before all you Star Wars fans come forth to correct me saying, well, nowhere in the entirety of the two current trilogies does it say a lightsaber is made of plasma, let me say, I mean, come on people, think for 1 second, can it really be made out of light? The blades can't really clash, meaning all of our beloved fight scenes would be ruined. I mean, they could flash each other in the eyes, but that's about as far as it goes. And while we are bursting nerds' bubbles, I would like to point out it's technically not a saber either. I feel as if I have gone miles off topic. Anyway, it is most probable, isn't that a nice word? Probable? Anyway, it is most probable that they will be made of plasma. And I'll reach the why in a minute, but first, let's start with the basics. Okay, so you guys realise when you heat a solid, it becomes a liquid. And when you heat that liquid, it becomes a gas, right? Well, if you then heat that gas, it becomes, you guessed it, plasma. The reason this happens is because by heating the gas, the electrons in the gas get so excited, which will, given enough energy, cause the electrons to break away. This will create a cloud of free roaming electrons surrounded by positively charged ions. This effect is not only caused by heating, but also by subjecting the gas to a strong electromagnetic field. Now, back to the lightsaber. You may be wondering, how does this cloud take the shape of a not-so-much saber? Well, plasma can answer that. Due to the presence of so many charge carriers in this cloud, the ions, plasma is made electrically conductive, meaning it responds strongly to electromagnetic fields. Well, similar to a gas, and implied by the word cloud, plasma does not have a definite shape, unless under the influence of a magnetic field. And before you say, yeah, but this is all just theoretical, well no, it is used in everyday life in filaments and beams. So, we can easily assume that this iconic not a saber shape is due to this cloud of energy being contained by strong magnetic fields. And unlike the they're made of light theory, as plasma is an actual state of matter, the blades will be able to clash. Woohoo! All the epic fight scenes are saved. Now we have the basics out of the way, and I have you thinking, maybe plasma works, but you need more proof? Well, feast your eyes. Remember on episode 1? Yeah, that one. The one we all try to forget. Anyway, at the beginning of the film, we see Qui-Gon Jinn use his lightsaber to cut through a blast door. Assuming this is made of steel, he would need to reach a melting point of 1,363 degrees Celsius. Well, even, and I quote, cold plasma is several thousand degrees Celsius, and that's just the cold stuff. Convinced yet? Maybe not. Okay, remember all those rainbows of colours presented in front of us during the entire franchise? Well, the colour of plasma is a result of the relaxation of electrons in excited states to lower energy states after they have recombined with ions, which simply means the different gases used to create the plasma create a range of different colours. For example, if you were to apply a strong electric current to helium gas, it would create Mace Windu's iconic purple lightsaber. Now we all have a basic idea of plasma, we can talk about how it is harnessed in the real world. It's already been around for a while. Did you know lightning is plasma? But how can we utilise this in our future? Well, ladies and gentlemen, we already use it. Dun dun dun! We use it in plasma torches. I know, it's given away in a name. Anyway, we send a gas through an electric arc formed between two electrodes to create a small plasma jet. These are largely used in industry, although use of plasma has started to be used in medical care, which is proof plasma is a fairly useful state. However, before you start waiting for the companies to bring out their brand new must-have lightsaber, with our current technology, it takes large generators to power plasma tools. It takes between 2 to 6 kilowatts an hour to power, and we simply just can't fit this into the hilt. But that doesn't mean it isn't possible. So, if you wait long enough, one day, lightsabers may be a reality. Anyway, I hope you guys did enjoy my presentation on plasma and enjoyed my way of showing you its properties. If you have any questions, don't hesitate to ask.